Hi everyone, I'm Adam. In this problem, for the graph of the polar equation given by r equal to 6 plus 3 times cosine theta, we're going to test for symmetry with respect to the line theta equal to pi over 2, the polar axis, and the pole. So we'll go ahead and get started by looking for symmetry, say with respect to the line theta equal pi over 2. Now, how we test for symmetry here, right, is making the substitution. We think of coordinate substitution. So for r and theta, we could substitute the point, say, r pi minus theta, or the point negative r negative theta. And the way this is going to work is in our equation, we're going to replace the r with the given r values and theta with the given theta values. And if after some simplification we get the same equation back, we know that it's symmetric with respect to that given line. Say here, theta equal pi over 2. Now, if it works for one point, we don't have to check the other ones. But if it doesn't work for one point, we'll check both, because it could work for one or the other, as we'll see. So let's go ahead and take a look. So we'll look at our first point here. So r in for r just leaves us with r, and that's equal to 6 plus 3 times cosine. Now instead of theta, we're going to substitute pi minus theta. Okay? Now what is cosine of pi minus theta? Well, a quick way of taking a look at this is that if we think of the base function, kind of getting rid of the pi, we have cosine of negative theta. But cosine is an even function, so cosine of negative theta is just the same as cosine of theta. So really what we have is thinking of the graph of cosine of theta shifted to the left by pi. And if we shift that graph to the left by pi, or by adding pi in here, that gives us the graph of negative cosine of theta. So with negative cosine theta, that means we have the equation r is equal to 6, say minus 3 cosine of theta, which is not the same as our original. So this one is not going to work. Now we can try the other point, see if that will work. So taking negative r for r, so we have negative r is equal to 6 plus 3 times cosine of negative theta. As we said, cosine is even, so cosine of negative theta is just equal to cosine of theta. And bringing, say, our negative over to the other side, that gives us the equation r is equal to, with a negative, we'll have negative 6 and negative, or minus 3, cosine theta, which again is not the same thing as our original. So this point doesn't work either. So what that tells us is that the graph of our equation is not symmetric with respect to our line theta equal pi over 2. Let's go ahead and move on. So let's now take a look at, well, if it's symmetric with respect to the polar axis. So here, same thing. We can look at substituting our coordinates, say r theta, for the polar axis. We can use the substitutions r theta for r negative theta, or we can have negative r pi minus theta. Okay, and let's take a look at this. So making the first substitution, well, we'll have the equation r for r, is equal to 6 plus, well, 3 cosine, and for theta, we have negative theta, which, as we just said, is even. So cosine of negative theta is just equal to cosine of theta. So that gives us that r is equal to, well, 6 plus 3 cosine theta, which is what our original equation is. So again, this tells us that the graph of the equation is symmetric with respect to our polar axis. Okay, now last one. let's take a look at symmetry with respect to the pole. And same thing, we can make some substitutions of r and theta. We can use the points r theta for r, say pi plus theta, or the point negative r and theta. So let's take a look. So we're going to have the first point, r in for r, will give us r equals to 6 plus 3 cosine of in for theta, pi plus theta. Now, taking a look at what we're going to have here, what is cosine of pi plus theta? Similar to our conversation in the first problem, if we think of the base graph of just cosine of theta, this is the graph shifted to the left by pi units, and essentially that's going to give us negative cosine of theta. So what we get is r is equal to 6 would be minus 3 cosine theta, which is not what our original graph is. So can't determine symmetry with that point. And let's try the last one. So we have negative r in for r. So negative r is equal to 6 plus 3 cosine of just theta. Well, we can see if we solve this for r, multiply through with a negative, we get r is equal to, would be negative 6 and minus 3 cosine theta, which is not the same thing as our original. So neither of these 2 points work. So the graph is going to be not symmetric with respect to our pole. So there we are. Thank you very much.